Hello everyone, welcome to another Power BI related tutorial by Team Sidescope. In this part we are learning how to build Star and Snowflake schemas in Power BI for sales and budget analysis. And here you can see we have created three layouts: sales layout, budget layout, and this is like the Snowflake schema that is created. The basic idea is to understand what is the difference between a star schema and snowflake schema and how we can create these other layouts in Power BI. So let's get started with a step-by-step introduction of all the tables that are here and how can we create such data model. So our topic is how to build a star and snowflake schema in Power BI for sales and budget analysis. So star schema kind of looks like this, where all these different circles that you are seeing, you can consider them as different tables. And in Power BI, it is going to look something like this. You can see sales table is in center. Then we have date, product, manufacturer, customer ID, and campaign ID as a star schema. Like we have established relationship between these tables, and this relationship shape kind of looks like a star to us. So that's what we are going to do. So in the data set we have these tables. So we have two fact tables and we have 7 dimension tables. So here you can see these are our items or tables that we have, like address, budget, campaign, category, segment, customers, date, manufacturer, product, and sales. And if you want to see their structure, this is how sales table looks. So this is product ID, date, customer ID, who bought the product, campaign ID, number of units purchased, manufacturer's ID, unit cost, and at what unit price it was bought. So as you can see, we also have unit cost as well as unit price in the sales table. So the difference between unit cost and unit price is fundamental in business analytics, in business and analytics, particularly in profitability analysis. Unit cost is the amount it costs the company to produce or acquire one unit of a product, including raw material, labor, manufacturing overhead, shipping, and wholesale purchase price. And from whose perspective, it is internal business. And unit price is the price at which the product is sold to customers. It is also known as selling price or retail price. And from whose perspective it is external customers. This is the budget table where we have information of the scenario, date, value, and category segment ID. So you can see here, scenario is either it is a budget or forecast. So in fact tables, budget, forecasted, and budgeted values will be there. Now what is a fact table or what is a budget fact table in data warehousing and business intelligence? A fact budget is a fact table that stores budgeted, that is planned or forecasted values for various business measures. Where is it used? In data warehouse, business intelligence tools, financial reporting systems. Example fields in a fact budget table are: we have date, we have department, product, budgeted sales, and budgeted cost. So you can see what is the budgeted sales and what is the budgeted cost. Key points are it stores planned data as opposed to actuals, which are stored in a different fact table like fact sales. And it can be used to compare budget versus actuals for variance analysis. Typically linked to dimension table like date, product, department, etc. that you are going to see here. Like we have campaign, category, segment, products, etc. We have all those type of tables with us, like this is product information. So that's why understanding this is very important. What is fact budget versus fact actual in respect of aspect, like type of data? In fact budget we have planned and forecasted values. In fact actual, we have real and actual transactions. So like we have the forecast and budget here, and in sales we have the actual information of what unit price was there when this product was sold. And here it is used for forecasting and planning, and fact actual is used for performance tracking. Example measure will be budgeted revenue, and actual will be actual revenue. So from here we will see something like what is budgeted revenue, what is forecasted revenue, and what is actual revenue can be found in other table. So once we have information of these tables, I know information will take time because we have so many tables with us, and the goal is to build a different type of schemas like Snowflake schema and Star schema. So first we will load data into Power BI. So we can open Power BI desktop. Obviously this is easy. So you will just click on Excel workbook here, and wherever our data sets will be stored, we will open. So these are the tables. We will connect them one by one. So I can put them in a same sheet also, but I am connecting them one by one. So this is address table where we have address information of customers. We will load it. We have got the data set from this particular Kaggle URL. I will put the link here, or I will simply give you the file separately, and we will rename it as address. Similarly, we will insert, we will go to home tab, and then we will add budget. So we have budget here. Open in budget also we have sheet. So we will load it. And what you can do, you can also put them all together in one Excel file, then loading will be easy for you. So, and we are going to rename it as budget. So I will follow the same step for all the tables that we have. So now you can see all the tables are loaded. So this is address, this is budget, campaign, category segment, customers, date, manufacturer's name, products, sales. In every product we have category segment ID, and this category segment ID is present here, and this category segment ID is also present in budget. So this is how we can actually relate them. So when we will create the relationship, you will understand that. Now our step 1 is complete. Step 2, create the first star schema. So in the model view, identify the sales table as your fact table. So when you will go to model view, so this is basically report view, table view. This is model view, and in model view you will find that many tables are there, and most of them are automatically linked. Okay, like we did not create this, but based on the column names etc that were there, so these tables are automatically linked. But we are going to create our own schemas as well. We are going to create the star schema and all. So here we will create new layout. So this is the new layout. Set up your layout, drag table to the canvas, and them to your layout, or select auto layout. So you can try do these two things. Now another question is how to identify sales table as fact table. So there is no formal fact table label, but you can identify and treat a table as fact table based on its role and structure. So in Power BI desktop, in our model view, remember fact table contains numeric measurable data, that is units, unit cost, unit price. Okay, and foreign keys that link to dimension tables. So for example here the sales table, when we see it in table view, the sales table contains information like units, unit cost, and unit price, which we just discussed. It has customer ID, that is linking to customers dimension view, campaign ID that is linking to campaign dimension table, and with the help of these two we will be able to link them. Third is another foreign key here, which is product ID, and this product ID is linking to the products table. So in products table, product ID is primary key. In sales table, it is a foreign key. So that's how we can identify a fact table. And whenever we are creating a layout, just drag it and put it in the middle. Like, we are, because we are going to create a star schema. And if you remember, this is the star schema. Okay, like sales will be in mid, and then we will drag others. So connect it to the following dimension tables, like customers via customer ID, product via product ID, date via date ID, and campaign via campaign ID if you want. So for example, products, we will drag products here. Okay, then we have customers, so I will drag customers here. Then we have date, so when we are adding date, you can see it is not identifying that. So one way is to, because we have date here and date here, we can tell that these are same, so we can drag and link them together. Okay, so we have date here. Now although we have only one manufacturer here, but we may have different manufacturers or vendors providing products to us. So here only one manufacturer, I have named it at VAD. So this is there. So we are going to link that manufacturer also. Okay. And finally there will be campaign. So currently in the table only campaign ID is given, but ideally you will also see information of campaign name, what type of campaign was it. Okay, so but these campaign names can be something like summer sale 2014, Diwali, Christmas, Eid, Dashera, whatever type of discount, Black Friday, Blast. This type of names can be there for these different campaigns, and that way you will be able to identify which campaigns has given us more sales, which campaigns are more successful than others. So that's why we are going to add campaign here, and that I am going to add on top. So this is how you can create the same version of that particular document or that particular image that I showed here. So now we can name our layout, and we can call it sales layout, because in sales layout we have the information of sales. Now remember, at the starting I told you there are going to be two fact tables. One of them is sales and one of them is budget. So now we can also create the second star schema, that is for budget. So we can identify budget as your second fact table, because it also has those columns like some foreign keys, some numerical information. So for example, we have the budget table here, and in the budget table we have scenario name, whether it's a budget or a forecast. We have date, we have value, and we have category sales ID. So obviously date is also linked to date, and category segment ID, sorry, is also linked to category segment here. So in this layout, which we already have here, which we are going to build, budget will be on top, category segment and date will be like that. So we will go there, and in this we are going to create another layout. This is budget layout. Okay, so in budget layout we are going to create, or we are going to put the budget table in center, because this is main. Then we are going to add date on left hand side or right hand side, and category segment. So it will automatically recognize this. For date I will just drag it here. Remember, anytime if we want to edit some relationship or understand its properties, you can see in budget table we have date, and in date table we have single date. This date table basically contains information of starting date, to end date. Okay, so starting date of sales 1 January 2011 to the end date, whatever is there in the data set. So this was already given, I just copied it, but this is something that you can create using the calendar function as well, and that I have explained in other tutorials also. Important thing about date is here year, quarter, week number, month, month as a name, and day of week as a name. Everything is given as a specific sheet or column. So now we have the second schema with us, and just for better understanding of everyone, I will just you know convert this to a Snowflake schema. So for that you can break out some dimension details, like from product to category segment, from customers to address. You can update the relationship. Product connects to category segment and manufacturer. Customer connect to addresses. So for example, we can connect addresses to customers, because in addresses we have customer ID, and if you look at it, we have zip code here. So when you see both tables, zip code it is common between them. Similarly, in products and category segments, we have the category segment ID. In category segment, we can select budget. With budget also we have date. So like this is the entire layout. Obviously by default it will be there, but you can build these two layouts and then you can kind of combine them together. So now if you switch from tables to model view, in your semantic model we have cultures, English US. Main things are relationships, we have 9. Budget category segment is connected to this, budget date is connected. How these tables are connected, you can see in our tables we have these 9 tables. So this is something you can try, and this is our Snowflake schema that we created. So best practices are, obviously we are going to build visuals in the second part and create some measures. Prefer star schema for ease and performance. Use Snowflake schema when dimensions are reused across models. You want to normalize data. Always use shared dimensions like date, product for fact to fact comparisons. Set up proper data types and relationships to avoid filter ambiguity. So now we have the Snowflake schema. How you can tell? The central fact table, in this case the sales table, is connected to multiple dimensional tables. The dimensional tables are normalized, meaning some dimensions are broken into sub dimensions. Okay, that we did. Fact table sales contains foreign keys like campaign ID, customer ID, product ID, manufacturing date, etc. Contains measures like unit cost, unit price, etc. And there are these dimensional tables. Key features in making a Snowflake and not a star: normalization of dimension tables like product category segment and customer address segment. In contrast, star schema would have denormalized flat dimensions connected directly to the fact table. So this was the first part of this project, where we created the schema, where we created the model, and in the second part we will start analyzing this data and create some visuals.